Hi guys, welcome to the second video of my channel. I'm the power of logic. So today I'm gonna tell you guys a complete number system. Let me write it out. And also, I'll introduce you guys a little bit of trigonometric knowledge about a different representation of 1, okay, and -1. So first, let's say number system. So every number is a complex number. That's included every number, okay? So this complex number, so this means that every number in the number system can be expressed as this. This is a standard form, complex number, okay? So this is every number, including real number and imaginary number. So this extended to two branches of real number and imaginary. Real number is every number except I. So I is the only imaginary number. And real numbers include a lot of things. Real number can express mainly as positive and negative. Okay? And so positive is any number that's larger than 0. And negative is any number that's less than 0. Okay? And we can expand this further. Positive can be rational and irrational. Irrational is obviously not rational number. And same as negative. The rational number is every number that can be expressed as a fraction. For example, 1/2, right? 2/4, 1, 2. And irrational is anything that cannot be expressed as a fraction. So irrational is like √2, √5, or even a fraction that repeats forever, like 1/9. You can't really have a number that's like a decimal answer, right? You cannot like really have like 0.5. It's like going forever and forever was not an end. And rational, we can include it as whole number. Whole number. Any whole number can be 0 and natural number, which we express it as n. Okay, so natural number is any number, like let's assume it's x, that's greater than 0, not including 0. And 0 remains neutral. Okay, and let's say negative, it's just like literally the same thing, right? But negative can't be whole number, so it's only rational and irrational. Just 1/2, -1/2, -1, and irrational is like negative. It's like -1/9. Okay. Let's start with imaginary number. Imaginary number is I, negative I, 5i, anything like this. It's imaginary number. So this introduces us a plane, new plane. So before, when we first learned math, that's like pretty bad, right? Let's just assume this is let's just assume that this is a straight line, okay? So before, we have a number line that's like this, okay? This is positive number, and this is positive, and this is negative. This is also negative. And we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is x and this is y. Right? But then today I'm going to introduce you guys a new plane called the complex plane. This is basically, so this is a real number plane. This is imaginary plane. Right? So basically this is 1, this is 2. This is negative 1, negative 2, negative 3, negative 4. This is, the x-axis is the same, but then the y-axis becomes 1i. Is it I? 2i, 3i, 4i, and it goes on forever. And this is negative I, negative 2i, negative 3i. So basically, any number like 2 is just equal to 2 plus 0i. And negative 2i just equal to 0 minus 2i. Which means that every number is just, so any number, okay? Any number x is just an element, complex number. Okay? Okay. Now I'm gonna introduce you guys different representation form of negative 1 or any number. Okay? So for example, let's say if I want to express negative 1. Negative 1 can be negative 1 for by itself, right? But then it also can be negative 1 plus 0i. And then it can also, okay, and there's a third one. The third one, how are we gonna explain? So this is the Euler's identity, right? That, so this is like e to the I pi is equal to anything is equal to 1 times cos e I theta, no, it's e I theta is equal to what? So I made some mistake here. So this is e I theta is equal to 1 cos times cos theta plus I times sin. And this is the polar form. This is the polar form. This is the polar form of any complex number. So everything like n plus ki, right? So this is basically I sin theta, and this is basically I times, and this is basically cos theta. Okay, and then how are we gonna notice is the unit circle? It's a pretty bad circle, right? Wait. This is on a complex plane. Complex number. This is an imaginary line. Pretty bad writing. This is an imaginary line, and this is a real number line. Let's add arrows. Okay, so this is a 90-degree angle. Okay, 90 is basically just 0, 1 on a complex plane. This is 0 degree, and this is 0. No, this is 1, 0. So basically, the circle is a rotation. Okay, and this is a half circle. So this is under 80 degree. This point under 80 degree, just -1, 0. Which, so this is a unit circle, okay? And this is 270 degrees, equal to 0, -1. And each of the angle, any theta, can be turned into radians. Okay, so radian is another representation of any circle, no, of any angle beside degrees. So radian, you just multiply any degrees times pi over 180, because 180 is equal to pi. Okay, remember this, and this will be really helpful in future. Okay, so therefore, any of the angles can be represented as a radian measure in this, in polar form. Okay, so basically I just want to list to you guys that, so there are specific like measures in a 30 degrees, 60 degrees, and 45 degrees, and etc. that are like in a irrational number form, but then these are the main stuff, and this gets really closer, right? So basically this must be a radian measure. So what does that mean is that, so -1, so what does that mean? So let's say it was under 80, right? Under 80 is -1. So -1 is 1 times cosine times 1 times cosine pi plus I times sin pi. And this went back to the Euler's identity. This went back to the Euler's identity, right? So what we get is EI theta is equal to cos pi plus I sin pi. No, cos theta plus pi theta. Okay, so it's basically just equal to E pi I. And there's a formula, you really have to memorize it. Okay, so if e pi I, that the factor of pi, the factor of pi is not divisible by 2. It's not divisible by 2. So it's basically just like it's a single number, okay? Not divisible by 2. Then and let's say the factor is x. N is a real number. Then what we know is that then e pi ex pi I is gonna equal to -1. Okay, that's really simple, right? And that's because 1 is literally under 80 pi's. It's under 80 degrees. Pi is equal to 180 degrees. So it's basically on the plane, it's -1, 0, which is -1, right? And so if e to the x pi I and x is an element of natural number and x divided by 2 is a whole number, is a real number, then this means that e to the x pi I is equal to 1. And yeah, I mean, so therefore there's like an infinite representation of 1, -1, because because these numbers are basically just rotations on the complex plane. So every 300 degrees is equal to 1, okay? Therefore there's like infinite. Like 1080 degrees is still 1, okay? And moreover, if ex pi I, if x is a fraction, x a fraction. No, x is n over 2. It's ugly. If x, so x must be a 0. It's a fraction that's like 1.5, like 3 over 2. Okay. If x is 3 over 2 and x is equal to a single number, plus 0.5, then it's gonna equal to 270 degrees, which is equal to -I. Vice versa, if x is a no, is a not. If x is an odd number, plus 0.5. If x is an even number, plus 0.5, then gonna equal to 90 degrees. Because it's literally just 1/2, right? 1/2 of a complex plane, of a rotation of a complex plane. Okay, so it's 90 degrees, which is I. Thank you for watching.